Hello, coming to you today from a secret location. If you know this location, please let your teacher know. That'll be a way of letting them know that you've watched this video as well. So today we will be looking at chance experiments with equally likely outcomes. We're starting with a little experiment. Now in my secret location, I don't happen to have a cup, so instead I'm going to be using a lid. In our first example, we'll be talking about Jamal, who's a 7th grader, and he wanted to design a game that involved tossing paper cups. So he tossed a paper cup 5 times and recorded the outcomes below. Now an outcome is the result of a single trial of an experiment. So here are his results. Now he noted the paper cup could land in one of 3 ways. It could land on its side. So with my lid, this would be the side. It could land right side up, which would be this with my lid. Or it could land upside down, which is this with my lid. Okay. The collection of these 3 outcomes is called the sample space. The space of an experiment is the set of all possible outcomes. For example, the sample space when flipping a coin would be heads and tails, because those are the 2 options or outcomes that you could have when you flip a coin. The sample space when drawing a color cube from a bag that has 3 red, 2 blue, 1 yellow, and 4 green cubes is red, blue, yellow, and green. So again, the sample space is simply the possible outcomes. We'll write that down. So I just made a note here that the sample space is the possible outcomes. Now, for each of the following chance experiments, list the sample space, all the possible outcomes. Drawing a color cube from a bag with 2 green, 1 red, 1 blue, and 3 black. So the sample space here is green, red, blue, and black, because those are the only options for colors of a cube that we could draw from this particular bag. Moving on, the sample space for tossing an empty soup can to see how it lands. So with a soup can, it would be just like the cups. It could land right side up, upside down, or on its side. Make sure you've have that recorded, and then we'll move on to the next page. Pause if you need to. Now this one somehow lost its number, but we can still do it. We're shooting a free throw in a basketball game, so there's only 2 outcomes. You either hit it or you miss it. Okay, so I'm going to let you take a moment and do the next 3 on your own, and go ahead and pause the video, do those 3, and then check back in. Okay, so for the number cube with numbers 1 through 6, the sample space or potential outcomes would be 1, 2, 3, 4, 5, and 6. Now, if you notice on probability, I didn't actually spell the whole word out because some of the letters are repeated. So, for example, B is only listed once, even though there are 2 B's in the word, because for the sample space, B is an option, and I would not need to repeat that. And then for our spinner, we have numbers 1, 2, 3, 4, 5, 6, 7, 8. Now on the spinner, they are out of order, but those are the numbers that are there. Therefore, those are the options or the sample space that we could expect to get. Okay, so for example 2, this is where we're actually going to do the paper cup toss. And if you're at home, maybe you have some type of paper cup that you could actually toss and do the experiment. I'm going to use my little lid since I don't have a cup. And with that, I'm just going to toss it, and I'm going to record my outcomes. Now remember that the potential outcomes, also called the sample space for this experiment, would be upside down, right side up, or on the side. So I'm going to pause this, and I'd like for you to pause yours as well. You do the experiment, I'll do the experiment, and then we will look at our results together. Now, are you expecting to get exactly the same thing that I get? I wouldn't expect that. Okay, I made a little key here for upside down. on the side or right side up, and then I recorded. And the reason mine have numbers is because when I finished the experiment, I went ahead and counted how many of each I had. So there's my experiment. Now the next page has some questions, and I've already counted mine. Kind of thought that we might have some questions coming up. Sorry about that. Okay, so using the results of our experiment. Now your answer is going to be different than mine because it's based on your experiment. What is the estimated probability of the paper cup landing on its side? Well, for me, it happened to be 10 out of 30, which is 1/3. So in that situation, the experiment actually matched what would happen in theory. So that's pretty neat. I wonder if yours did. Using the results, what is the estimated probability for it landing upside down? So this one wasn't textbook perfect, but it was pretty close, 11 out of 30. The next one, the probability of the paper cup landing on right side up, I got that 9 out of 30 times. I am going back to put in my probability notation, and I suggest that you do that as well. Sorry about this. I don't have the best setup here. Okay, so then the probability of the side would be probability of the side, like that. Okay, based on our results, do you think the three outcomes are equally likely to occur? I do. There was not anything that would make it a better chance landing one way than the other in this situation. It happened to not be perfect, but if I had done this experiment 10 million times, it would be closer to perfect. And by perfect, I mean the experimental probability matching the theoretical probability. Okay, so here we've got a spinner, and the first question is, are the events of landing on a 1 and 2 equally likely? Well, the 1 and 2 have the exact same amount of space, so I'm going to say yes. What about 2 and 3? Are they equally likely? And that would be no, because the 3, the area of space for the 3 is twice the size as the area of space for the 2. So no, the 3 has a larger space. And if you actually kind of separated it, so we had even pieces, you could see there would be 2 sections that would have the 3. How many times do you predict the spinner will land on each section after 100 spins? Well, when I see 100, I automatically think percentages. So this is 25%. This is 25%, which means these 2 spaces would be 50%. So the probability of 1 is 25 out of 100. The probability of 2 is 25 out of 100. And the probability of 3 would be 50 out of 100. So I went ahead and pulled out my inner artist to draw this one out. I've just drawn a spinner with 3 equal sections. And I know it's not perfect, but that's all that my inner artist can do. And then it says, how many times do you think the spinner would land on each section? Well, if I took 100 and divided it by 3, I'd get 33 1/3. So it's probably going to be 33, 33, and 34. Because you can't do 1/3 of a land. Alrighty, so there's that. Now you go ahead and do the problem set. Enter your problem set, and then there will be another video for you to watch to check over your problem set. Did you figure out the mystery location?